This is the Energy Mortgage Workshop for the Heartland Renewable Energy Society, or HRES, and we happen to have Shauna Zahner, who has designed the home that Bob Solger has built. And so we had an earlier workshop, the HRES workshop that was before this one, featured Bob's home and a tour of it and a description of the solar and all. And this now is taking the information about Bob's home and a kind of a pre and a post session, in that we're doing the pre now, or before the solar was added, with the home, just the home itself and the home data, and then we're going to add some of the energy and solar features in another segment, put it all together for the workshop, so you can see what an energy mortgage would help pay for and not pay for, and just the whole process. But to do this, we're not using the software that raters use as far as the national software. What we're using is a data collection tool called REM Collect, and we're going to use a project management tool called REM Check, and they can feed energy modeling software, which we won't even name right now because it works with pretty much all the energy modeling software out there in one form or the other, and eventually it will work with all of them. But right now what we're introducing is the REM Collect aspect of this, which is the data collection tool that a home energy rater, an energy auditor, a rating field inspector, basically a residential energy professional, can take into the field with them using their phone or a laptop or any other mobile device and input the information on the fly. Once they get all the information input into the system, then they can upload it into REM Check, and it creates a instantly openable .blg file for anybody watching this that's an energy person, that can be opened with either REM Rate or REM Design by Noresco. I said I wouldn't mention them, but now I did. So bottom line, it automatically creates files for that particular software program right now, but it'll also connect with others in time. So what we're going to do is walk through this and add the information on Bob Solger's home. And to do that, we've already put in some information. Now, of course, this isn't his actual address, and I'm not going to disclose that, but Bob has a single family home. It faces north. The year built is not 2020, so we're going to change this. Shauna, it's 2018, wasn't it?
It is. That's correct. They did move in December of 2018.
All right. And it says number of bedrooms, 12,150.
They have 2 bedrooms.
Okay.
Let's get 12,000 bedrooms. Yeah.
I do believe that 12,250 was supposed to be down here under conditioned space. Let's do that. Okay. So there's one conditioned floor above grade. There's 2 floors overall because there's an unconditioned basement, under a partial basement under part of it, and part of it's on a slab. Is that correct?
That's correct.
Okay. We have 1,305. I didn't change that. 1,305 conditioned square feet, and volume would be basically 9 times that number, which I don't have my calculator right here, but I'll do it real quick.
11,745.
What's that?
11,745.
Which I should also say 11,745. Okay. Before we go any further, we happen to have on this conversation 2 different people besides myself. I'm Ken Reed. We have Shauna Zahner, who I did introduce earlier, but she designed the home, and then we have my wife, Charla Reed, who's also on the line because this is the software program that she has built, and I want to make sure I explain the software correctly, so she's going to monitor this and make sure that we input the inputs, I guess, the best way possible. So we have put in here it has 2 types of foundations, an unconditioned basement and a slab. And then I don't know if it has an attic fan or not. I assume not.
Nope.
Okay.
Not. Nope.
And drywall thickness, that should probably be like 1/2 inch drywall around the home.
It's either half inch or 5/8. I don't know which exactly,
Okay.
but we can probably go with half inch.
All right. So that information is all you put in on this screen, as far as I can tell. Yes. Okay. So now I go back up to the upper right and I click on Home, and that takes us back to the input screen. That's all we could put in, or that's the basics for the property info part of this. Then we go into data collection. And you start at the top, and the reason that they're in this order, and so this maybe Charlotte will jump in at some point to if it's, if it makes sense. But this is in the order typically that an energy professional who goes to a home does the calculations and does the measurements, walls, windows, doors, ceiling, floor, and then you get into the counting of things like lights and ceiling fans.
Okay.
So in the walls, and I already calculated out that you've got, let me see if we can bring this up, for the one above grade wall, and the goes to the outside, medium color is what we called it. Now, we have SIPs in here, but for some reason it's not accepting it, so
Go ahead and try it again, hon.
I just did.
Oh, okay, we can't see the drop down. Okay.
You can't see the drop down?
No,
Okay.
it's okay.
So that's right. We're just gonna have to fix this.
You may have to log out and log back in, or synchronize and then log back. Maybe that's the problem. We didn't synchronize it.
Okay. So what do I
So
do?
let's try that real quick. Just go back to Home and then Options. Options. It's up top right. There you go, and hit Synchronize Project.
Synchronization.
It's complete.
Synchronization
Okay.
So just click OK,
complete.
and now click on the property again to select it. And now go back to your wall and let's see if we can, because I think that's the problem.
Edit the first
that.
wall, and then the construction type says none.
Right.
Ah,
Do you
it
see?
took SIPs this time.
Yeah, SIPs.
Yeah. Sorry, that was the problem. We needed to synchronize.
Okay.
Okay.
Okay. Because we added that as a new construction type, and then we didn't synchronize it, so it lost it.
Okay.
Ah.
And those are 6-inch depth SIPs
Oh, okay.
Oh, okay.
as opposed to 8-inch. They're,
Okay.
or
So
actually, they were probably 6.5, but I think.
I can make them 6.5.
we were guessing. So you can go back to construction types and edit that if you want, and then synchronize again, and then we can have the right thing.
All right. So to do that, we go back to Home, and
Options.
we go to
Options.
Options. The construction type
construction
list.
type list, yeah.
And then we got SIPs, so we're going to edit it. And
Yeah.
we don't need to add it, we just have to edit it. So it's
So-
6 inches, 6.5.
Yeah, I think they're 6.5.
So 6.5 inch depth.
Mm-hmm.
And change the name so it's,
Won't it do that automatically?
there you go. Yep.
All
Just
right.
did. Save.
Okay. And then if we get back out of this, by clicking Home again, go back into
Go back to
data.
options.
Oh, go back to options?
Yeah, you want to synchronize it.
Oh, right. Done.
Okay. Okay.
I'm not going to try to say it again. All right, so here we are, back in the same property. Home,
Yeah, you should be.
data collection, wall, edit, and the construction type should be
Pick
SIPs,
your new one. There
and
we go.
it's 48 inches by 6.5.
Yeah.
Uh-huh.
And
Well,
it says
What's the R value?
but it still says 8 here. Huh. Okay.
That's the height.
Yeah.
The height of
Cavity
the
ins-
walls is 8 feet, so that's
right,
correct.
but the cavity installation depth went to 8 inches again. So, do you know what
So
the do you know what
R
the,
value?
yeah.
I do not know what the R value was particularly.
We can get that from Bob then a little later.
It's well,
So our first foundation wall is conditioned to ambient. That is correct. Exterior color you decided was medium. Okay. That needs to be, yeah, not wood studs, but no, it's not SIPs. It's going to be 8-inch concrete. There we go. It's 33.34 feet long by 8 foot tall. That's the front and the back. So how far above grade is that?
Did I lose you
No,
or not? Oh, okay.
I can hear you.
Okay.
Let's see. I'm trying to look at the pictures to see how far above grade that one is. Oh, that's the other. Okay, now I see where that one is. Okay. That is probably, I mean, it's not very much above, sticking up above grade.
No, he probably just did the 8 inches.
Okay,
Right.
so 0.7, Ken. Yeah. And does it have insulation on the outside?
Yes, every bit of that foundation wall has in step 2 inches of pink.
Yeah, so that's R10 on the outside. So for the name, you can call it tall if you want. That's oh wait, the insulation top edge. It goes all the way up to the top of it. So it'd be 0 to from the top and 0 from the bottom. That's fine. Leave those alone. And that's the tall walls. So save that, and then you're going to want to copy it so that we don't have to worry about insulation and all that again. This one is 4 feet wide. Yep. By 6 feet tall. And it is, first step if you want to name it.
Okay, I'm now going to summarize the online session that was had between Shauna Zahner, Charlotte Reed, and myself using the REM Collect tool. As you can see, it's easy to use. I'm going to step through it here and show you the remaining things that we put in during that session. We went to the property info, we put in the information about the home, we went back to the home screen, to data collection, went through the walls, which you saw that part, where we went through and added the walls, both above grade and below grade foundation walls. And then we go back to the home again and we go to adding windows, adding doors. As you can see, it's simply adding doors by adding a door. It's very simple to add a door. Unfortunately, not enough time to show every single option quickly. You had to put in the ceiling area. So we have 4 different ceiling areas. They're all vaulted because it's a SIPS panel, structurally insulated panel system. So there's insulation is between the sandwich. There's no attic. Floor. Square footages of the different main areas of the home. Joists, in this case floor joists, underneath the main floor to help hold the floor up, of course. And that's another area that needs to be taken into account, especially for infiltration and insulation. So the areas between the band joist and the main joist are put in there. Lights. In this area, you count up the lights by just simply clicking. In this case, we had 10 LED lights. If I click here, it makes it 11. If I click here, it takes one away. This is designed so you can use a handheld device like a mobile phone and go through the home and just simply touch and add the lights, whether they're LEDs, fluorescent CFLs, or incandescents. Interior lights, exterior lights, 10 interior, 4 exterior. And then in the garage, we didn't add them up because if the garage was part of the home or the home environment, then they would be added, but the garage is actually in a separate building. So didn't worry about that. Ceiling fans, you add them here. We've collected data on 3 fans. I'll click on the main one just real quick. You can see, you can take a picture of it. You can write information about it, and you can put information here, like clicking to see if it's an Energy Star fan or what the CFMs are. There's some information that still needs to be filled out on some of these. We'll have that on the next round here that's coming up with Bob Solger. So we can put in the solar, clean energy system and flesh out the rest of this. Appliances. We have the information on the refrigerator and all that now, but when we talked to Shauna, we did not have that yet, so that's not filled out completely. Interior mass is something that you add if there's additional mass, such as concrete planters inside the home or something like that. Water heating and conservation, we don't have that yet. As again, out of the next session, I'll show you here in just a few minutes. Interior mass, we went through that. Water heating, HVAC, which of course is heating, ventilation and air conditioning, and water heating. We have that information as well. That's coming up. Thermostat, ductwork. We won't be putting any ductwork in this home, so that won't even change because the home has mini splits, which are considered ductless, and radiant floor heating, which obviously has no ducts. The photovoltaics we will add, which is the solar electric system. And also, if Bob has, which I don't believe he does, but if he had a hot water or hot air solar system, you would put that information in here as well. So you can see we've gone through and done what we can during the first session. And then I'm going to stop at this point and jump into the online conversations we had with Bob Solger about the remaining information we need to put into this. So I'll jump into that now.
Okay. How about your PV system? I assume it's oriented south.
It's actually southeast, 165.
And how much
100.
area of solar panels do you have?
Well, we've got an 8 let me see, always forget what it is, 28 times. 8.54 kW. And the physical area it covers is approximately 500 square feet.
Do you know what tilt it's at?
Yeah, 22.5 degrees. Yep.
Do you know your inverter efficiency?
97.5%.
Okay. Is it used to power only DC appliances?
No.
Okay. Wow, that takes care of that. All right. Do you have any space or water solar heating system?
No.
Okay. Well, then that's all our questions until we get the all the pictures of all the model numbers. Then we can finish everything else up.
That sounds good.
We got the photos from Bob on the equipment and model number plates, the energy guide labels, the appliances, and the solar panel installation. And we completed the REM Collect hybrid app that was used to input all the information about Bob's home. So when we go over here now and synchronize the project, this information instantly uploads into the REMcheck Quality Assurance QA platform for finalization. So when we go over to REMcheck, we can log in using our same login and password as we had for REM Collect. And it brings us to our, QA queue right now because I'm signed in as a quality assurance designee and there's nothing in there to QA. So we click on all jobs and we see our job here. On the project details screen in REMcheck, there's this green hammer icon. And when you click that, the system instantly converts all the information that we gathered and synchronized from the REM Collect tool into a building file. Let's do that now. There we go. That building file can be read by either REMrate or the REM Design energy modeling software. REMrate is the platinum standard for energy modeling software that's used by certified home energy raters across the USA and American territories such as Guam, Puerto Rico, and the US Virgin Islands. And REM Design is energy modeling software that can be used by builders, designers, and energy auditors. All of the energy models are maintained in the REMcheck tool so that you can review any of them from the beginning of the project to the end of the project. This green check mark icon is a self-check, that when you click on it, it's going to run this project through all of the self-checks, that everything that a computer can check to make sure that the model was performed accurately. It displays all of this information on this page for easy review. Any items that need correcting or require additional information or explanation are shown in red text, and there's fields, which I've already filled out, for communicating with the quality assurance person why you might have some red that you haven't taken care of yet. So in this case, we didn't select any programs such as HRES rating or Energy Star or anything like that, because this is for the HRES workshop. Some of these don't have a place to put a check mark just because they are failing the math tests and or the logic tests in the system. And for those, you can basically have a comment up here that you can explain to the QA why you're leaving those in the model. In this case, we do have a house with some unusual construction characteristics, and there is not a rim joist to ambient because the only rim on there is between the unconditioned basement and the dirt behind the house, or under the house, or the unconditioned basement and the ambient air. Things like that. And you can add check marks and reasons for unusual items that the computer checked, but this house has a reason for not having that. In this case, there's no door between conditioned space and the unconditioned basement. That's because there really is no door between conditioned space and the unconditioned basement. You go outside of the house and around it to the side, and then you can go in your basement. And there is no ductwork. So those have been overridden with a comment, so we know that they've been looked at, they've been considered, and they're good. You can also see all of the model items here, and so you don't even have to open REM rate or REM design in order to see the energy model. You can see it all on the screen within REM check, and it organizes it all nicely for you too. For instance, it puts all of the windows in their orientation order no matter how they were put into the model. You can see we had window 1, 2, 3, 4, and 14. Well, you don't have to scroll through all of the windows in REM rate to find all the ones that face south. They're all lumped together here in REM check. And once the person who just performed the self-check is done or has gone through and looked at everything, then they can submit their file to quality assurance. In this case, I'm signed in as a quality assurance person, so I'm not going to submit it to myself. It's just expecting that I am reviewing the file. So as the person is scrolling through and writing their comments and figuring out whether or not they've modeled everything correctly, they have the opportunity at the bottom, if they have to stop maybe and go to a meeting or go to lunch or something, they can save their work and not submit it to quality assurance, because that saves all of the comments that they put up at the top. Or if they want to submit it, they would have a submit to quality assurance button down here for any programs that the file was created for. In our case, we didn't add any programs, so there's no one to submit it to, but we can perform a quality assurance check and do a QA review, and our peers can do a QA review and things like that. So in this case, we're just going to save our work and not submit it because we don't have anything to submit it to. Brings us back to our portal, back to our job. The other things that you can see in the project details screen are all the pictures of the project. Your pictures are listed all right here. You can click on them to get a closer look and scroll through and see the pictures. And if you need to get an even closer look, you can click on it and zoom in. And you can also download photos from here. You can take a look at anything you need. Then you can also see all of the documentation that is for the project. So we've got plans, we've got energy guides, we've got HRI certificates, and if you want to look at any of the HRI certificates or any of them, you can also open them from here so you can take a look. So this is a very nice tool for programs to perform their quality assurance, because they can check and make sure that the energy professional, whoever's doing the model, has pulled everything in that needs to be pulled there. So since we're talking about energy mortgages here, and we're talking about energy models, if you're a homeowner or a builder or a contractor or real estate professional or basically anyone other than a certified HRES rater and you want to review your information in an energy modeling software program, you can download and use a trial version of REM Design. Ken is going to provide a link to get the downloadable trial version of REM Design at the end of the presentation. But what we did, I am a HRES rater, and I am a quality assurance designee, and so I have REM rate, and we have created a base model for Bob's house that is just built to meet codes, to meet energy codes. And we've already created an energy model of that in REM rate. And you can see right here our HRES index is 93, so it's a little better than code actually. It's 96 on 2015 energy code, and it's a 99 for 2018, so it's right at code. A code house will have an index of 100, and then an improved house will have a better index than 100. It's like a golf score, lower is better, so it would have a lower index number. But what we've done is we have created an energy model using REM Collect, and then which created this for us. You can see it actually even put notes in for us and explained in the notes what we had and what our equipment was and things like that. In this case, we have kind of a hybrid because some of these notes are from our previous working on the model, and they're going to have some of the equipment that Bob has, but in this model we actually took that out, backed it back out, and turned this into a code house. So the notes don't quite match the model. But you can see we've got our building information screen, we've got the organization information screen, we've got all our energy rating dates and information, utilities and weather station, closest weather station, the area and housing type and foundation type. All the foundation walls are in here. We've got our slab floors, frame floors, rim and band joists, all our above grade walls, and we took his SIPS walls, turned them into R13 walls, the windows and doors that are on those walls, and we did leave the same high quality windows and doors in our base model. That's why we're getting better than code, because the windows and the doors are better than code. And we also changed our ceiling to a code ceiling, and we changed our equipment to minimum code equipment, 13 SEER air conditioner and an 80 AFUE furnace, 40 gallon, 60% efficient water heater. So these are it's not good equipment, it's just code. It passes code though. So that is standard builder grade items with a programmable thermostat though. So we do have that. We did have to put in our ductwork because Bob's house does not have any ductwork. He's got mini splits, and so we put in the ductwork and estimated a pretty good leakage rate, better than we see in the field today in today's ducts. We put in 5 ACH for the blower door because local codes, that is what's allowed as far as leakage. And we did leave the ventilation, mechanical ventilation in there. So these are the things that are making it better than code, is because we did have that stuff. But one of the things that we wanted to do with this by turning it into a code house was perform an improvement analysis. And the improvement analysis is done by taking items that are in the existing house and saying how you're going to improve them. We did this already in a previous run, so I'm just going to click that and show you. So we have such as our walls. We said they were R13. We're going to upgrade them into an R48 SIPS panel, which is what he has. It's a SIPS panel plus some continuous insulation. So we're upgrading all our walls. We're upgrading our foundation walls to be from bare concrete to an insulated concrete. We're adding R15. We're upgrading our slab floors, our rim and band. Made our infiltration rate lower because SIPS panels will leak less. We only took it down to 3 ACH, which is what is actually required by the 2018 code right now that Kansas City is just adopting. And of course our duct leakage goes away because we no longer have ducts. And then we upgraded the equipment, the heating and cooling equipment, to match what is currently in Bob's house. So we have all of that, and we have not only what we improved, but what the costs were for that improvement. So the energy improvement analysis that is performed by the tool takes the existing, the proposed, and the costs into account, and then calculates the new energy usage with the improved house and tells you how much you're going to save, and takes all those costs into account as well. So when we say okay, we can then put in our economic factors, we can put in our how we want it to rank, what reports we want to see, and so we've got all that set. We need to save an improved one at this point in time. You can save an improved building file, so you have both of them. And then we have the opportunity to put in health, safety, comfort, and house durability recommendations that don't impact the energy efficiency of the house, but we want to have included on our energy improvement reports. In this case, we'll skip that right now. And we have our energy improvement analysis report. So you can see on the report that our total energy costs by year reduced from $2,539 a year down to $1,285 a year. That is what the improved costs will be. And then since this is an energy mortgage that we're seeking, there's going to be mortgage costs as well. There's going to be interest that you have to pay every month to the bank, so that actually comes up to $1,764 a year of savings. So your cost without making these improvements is $2,539 all in utility bills, and your costs with all the improvements is $1,764, including your utilities and your mortgage. So you can see that the installed cost of the improvements is $9,514. Now, one thing to keep in mind, that I need to tell you, is that this does not include the photovoltaic solar panel array. There is some problems right now with the energy improvement analysis process in the REM rate tool, in that it is not including photovoltaics at the moment, and they also have some problems with their net present value calculations. And this is due to a lot of code changes that have happened within the energy modeling and requirements in the new standards. There's some new ANSI standards that have come out that have changed the way that things are calculated. This is a good thing because it is making it much more standardized across the country, across all of the software tools that create energy models, and it has removed a large house bias that was in the old calculations for energy calculations. The smaller houses were actually coming up with higher indexes even though their energy savings were better. And there was some analysis performed on all of the energy cost calculations that were then standardized and normalized so that the size of the house didn't cause as big of a gap as it had been causing in the past. So all of these changes basically meant that the software had to be rewritten, and the improvement analysis is the last piece that is getting improved, shall we say. So the improvement analysis report is not yet quite done, and they are working on it. They have some more standards changes they have to make first, and then they tell us that the improvement analysis is in the queue and it will get taken care of. But at this point, we're going to ignore the net present value piece of it, and we're going to look at the rest of it because the other calculations are correct, and they do have the information that we wanted to run. For an energy mortgage, basically the bottom line is, as long as it's not costing you more at the end of the day here between your improved energy costs and your mortgage, then you're going to have a positive net present value, and you're going to be able to qualify for the energy mortgage. So this house does qualify for an energy mortgage. The installed cost of improvements was $9,514 without the PV. The cost weighted life of measure, which is in years, is 24 years. And what is going on here, and our mortgage you can see is 30 years. What's happening here is that each measure, as you put it in and say, I'm going to add SIPS panels to this house, I'm going to upgrade the equipment from X to Y, you have to also put in how many years is that improvement going to last. Some of those improvements will last the life of the house. And so 30 years is the most you can put in, which is also the mortgage term. And so we put in 30 years for those, but some of the improvements are not going to last 30 years. Maybe the equipment won't last 30 years. And maybe lighting upgrades would not last 30 years. So the cost weighted measure life is 24 years, and that's what this is telling us. So our improvements are lasting on average 24 years. Some of them will last the whole 30 years, some will be less. We're still saving money, and the part of that is brought into your net present value as well. Because if you have to replace it before the mortgage runs out, that has to be taken into account. Our mortgage rate we put in was 2.89%. We said there was a 10% down payment, and then it's telling us our expected annual energy savings are $1,254, which we can see here, and our increased mortgage cost is going to be $479. So we are actually putting an extra $776 in our pocket at the end of every year rather than sending it to the utility company. So this is not a cost. It doesn't really cost to make these improvements. It pays. This is an investment that is paying you back starting on day one. It is showing that basically what I like to tell people is that with an energy mortgage and energy improvements, you're just moving the money around. You could either be sending this money to the utility company, which is what's happening here, or you take some of that money you're sending to the utility company, send part of it to the mortgage company, to the bank, and you put part of it right in your pocket. So you're actually making money by making energy improvements. The next part of our improvement analysis report is showing us the list of energy improvements, the recommended improvements, in the order in which they save the most money every year. And so this is where you can see there's some of the messing up of the net present value calculations and the yearly savings. This should actually be a positive number. This is saving us the most money every year, and that's why it's number one. But it's some of these calculations are just not right yet. Infiltration is our next best thing to do. Upgrading the walls was the third best thing to do. And then the rim and band joist, foundation walls, getting rid of those ducts, those leaky ducts, and replacing the equipment. And then we get down to the slab floor. And that's only because the earth provides some of the insulation qualities of a slab floor, so you're increasing your insulation on something that's already partially insulated. And same thing with the ceiling. So your ceiling and your slab floor, due to the fact of the law of diminishing returns, are going to be less of an energy savings than some of the things higher on the list. That's our improvement analysis report. And then we have also requested an energy retrofit report, which is a report that comes to the homeowner and kind of gives them a better idea of exactly how this happened, what is going on. It explains some of the terminology that we've been using and talks about everything. We're going to take an R13 wall, we're going to turn it into a SIPS wall. We're going to take an uninsulated foundation wall, we're going to turn it into an insulated foundation wall. We're going to take our equipment and we're going to get rid of our furnace and our air conditioner. We're going to replace it with the new equipment. So we've got our list down here, slab floors, and this will give us a pictorial view of those things that are the best down to the worst as well. And we have a work order which tells us, here's how much of everything you have to purchase. Here's how many square feet of these things that you're going to need. Now, this is where the rubber meets the road. This is what you're really here to look at. This is the energy efficient mortgage worksheet. An energy mortgage has a couple steps. The first step is the buyer has to be qualified, and that is all filled out by the bank. And the second step is the qualification of the house. As we like to say, the buyer qualifies for the mortgage, but the house qualifies for the energy mortgage. The energy mortgage information is calculated and inserted into the form by RIM rate. So it's showing that we're going to save $105 a month. We're going to save $1,254 a year. And if there's any maintenance contracts and things like that, those can also be put into the improvement analysis. We're going to have our premium. This is the part that is not calculating correctly right now. We've got our installed cost. We can see if the home qualifies or not for the energy mortgage. Now, unfortunately, this report is not working correctly right now, but at least you can see what the format is and what it's going to contain once all the calculations and the information is correct. And then Fannie Mae has a little bit of a different format. Fannie Mae wants to have this with the list of all of the improvements that are going to be made. And then you have your improvement cost and you have a report cost, and that is because you are allowed in an energy mortgage to also finance what it costs to hire the energy professional to come up with this report for you. So you could put in the energy report cost and include that in that financing. And then your net present value, once it calculates correctly, would show up here, and your monthly energy savings. The rater signs it, you give that to Fannie Mae, and you are done. And those are our reports. Okay, now we did also perform an economic summary using the software to show what it would be with the photovoltaic system as well. And the economic summary showed us that even with the photovoltaic system installed, that made our improvement cost jump up to $26,514. But we've got and we only used a 20-year loan term on this one and a 2.9% interest rate. So it's actually, we made it a little harsher, and we still have a 14-year simple payback. So all the improvements, including the photovoltaic system, pay back for themselves in less than the 20-year loan term. It pays back in 14 years. And this is our first year savings, which is even in the first year, which includes our down payment and the interest on the loan, on the mortgage and everything, we are saving $73. Then we will actually be saving more than that every year after, because our total of savings is $1,837 when you include the photovoltaic system, and our first year cost was $1,764. So we start saving right from day one. So this house definitely would qualify for an energy mortgage.
Thank you, Charla, for that helpful and very detailed explanation of the software used in energy mortgages. We're now looking at the Heartland Renewable Energy Society website, the page for the helpful links to find out more information about the secondary mortgage programs, which we'll take a quick look at, and then we'll go into the question and answer segment of this workshop. So let's start, first let's look at the page here. If you click on this chart, it'll take you to the choice renovation mortgages offered by Freddie Mac. Also have links here for the Fannie Mae Homestyle Renovation Mortgage Programs, the FHA HUD Energy Mortgage, and the VA program. So we'll look at each one real quick. Start with the Freddie Mac. It's actually a PDF in this case that pretty much details the program. And if you scroll down just a little bit, about the third page or so, you'll see the very same chart that I have on the Heartland Renewable Energy Society HRES website. And it's really an interesting example. What they have here is the single-family residence was purchased originally for $75,000. The cost of the improvements is $180,000, which obviously is more than double the price of the home original cost. So the acquisition of the property cost, the entire amount is $255,000. As completed value of the property is $250,000. So basically they're willing to loan under this energy mortgage program more than double the original amount of the home. And then over here, the maximum allowable renovation cost is 75% of the value of the home. Since it will appraise at $250,000, what they're saying is that they'll give you $187,500 toward the improvements, which is substantial. So now I'll point out a caveat here that what this is really saying is that the home was probably not in good shape, because if they're going to let the as completed value of the property be at $250,000, that means that there are other houses somewhere in the nearby proximity that's also worth around $250,000, give or take, because odds are they won't give you a lot more money than the value of the homes around you, simply because that's just how appraisals work. They look at what they call comparatives or comparables. And so you're going to need to make sure that if you do this, you have a home that needs some repair, which pretty much all of them do, and likely your cost of repairs and everything will not exceed by much anyway the value of the surrounding homes. So anyway, here is information about the choice renovation, and it's basically the energy mortgage program offered by Freddie Mac. Next, we'll look at the Homestyle loan program. home-style renovation mortgage. It was what they called their energy mortgages. And so there's basically generalized information here. These links do not get too specific, but I'm going to go back to the top. I know I'm scrolling fast. Shouldn't probably do that, but so it's got information on purchasing a home that needs some repairs, that's in this repair. Then it has information on refinancing a home that you own, how to upgrade it to be better for your needs. And I think if I scroll down here, which I'll add this link to the HRES website, you can click to combining the renovation loan with their home-style energy loan. And now we're talking definitely their home-style energy mortgage. And it talks about money spent on disaster-related repairs in 2015 from a study in 2017. Of course, we know every year the cost of repairing from disaster-related events is going up substantially. So they want these loans to be used for rebuilding, improving. And that's their information. Of course, you're going to have to do a little more research than what I'm showing you to get the information you need if you think you might be interested in any of these programs. So we started with the choice renovation with Freddie Mac. We're now looking at homestyle, and next we will look at the VA program. And to be honest, I have studied their website and looked pretty much at every link they offer. I do not see where they offer an energy mortgage program at the current time. If they do, I can't find out where it is. So I'm going to say, just for the sake of where we're at, that I don't think VA has an energy mortgage program at the moment. Doesn't mean that they won't in the near future, but what's happening with all the secondary market loan programs is they're inundated with requests to refinance due to the low interest rates. And so I've talked to the actual folks at some of these programs, the people who run them, and they just don't have enough. They don't have 2 minutes to rub together right now. So that means the energy programs, the energy mortgages, are going to probably be a little backburnered for a while, but I expect them to come back because we have to rebuild the nation's housing stock at least as good or better than it was, and especially to make it more resilient to disasters. Okay, this next and last website we're looking at is the HUD Energy Efficient Mortgage Homeowner Guide. And so it goes into, again, a generalized description. They want you to get a home energy assessment, which of course they're talking about a certified HRES rater and a qualified, I don't know if you can see this very well, but it's saying qualified energy assessors are basically trained and certified as one of the following: Building Performance Institute, BPI, and that they really aren't going to be able to do the final part of the energy mortgage. They also talk about energy auditors, but what you're really looking for is a Residential Energy Services Network home energy rater, a certified home energy rater. And that's my final advice as we're looking at this and the programs, is you really need to start with a certified home energy rater if you want to do this. Research is great, and learning what you can about the programs is important, but trying to figure out how to do all this on your own, it's overwhelming. And so the people that can help you the most are certified home energy raters. And I'll leave it at that, and I think it's time to go into the question and answer period and let you know that we appreciate you watching this, and thank you very much.